In this section we will deal with the topic of input and input redirection. In particular, we will see how the bash understands, for example, if two elements are separated or if they're just one whole element. And we will do that by working with the internal field separator of the bash and seeing how we can change it to our interest. In this lesson we will see how to take an input to multiple values with the read command and how to use the here string command with the read command. The nice thing about the read command is that it can read multiple variables. So for example, if we type read and then we use the variable a space b space c space d, and then we hit enter, and for example as a first variable we use 10, and now I use a space and I write 20, and I use a space and I use, I don't know, hello, and then let me write, for example, house, dad, and I hit enter. Now if I try to access those, we will have in A there is 10, in B there is 20, in C there is hello, and in D there is house. And so this is a very powerful and fast way to get multiple variables. And let me show you something about that. Let's say that we do again something like this, and now I put 10 here and then 20 here and then 30 here and then 40 here and then 50, 60 and 70. So I give more values than I have here. Now let me show you what happens. In the first four we don't have problem. The first one is 10 as the second, and the third one everything is okay. And the fourth one, what happened is that since it interprets this as the last one, when I give the program these values, it interprets this, all of this, as the fourth one, because I told him, hey, you're gonna get 1, 2, 3, 4 variables. And so interpret this as 1, 2, 3, and then for the system that must be the fourth one. So the fourth one, the variable d, is given the value of all of this. Now let's go to the point about redirection. This point is important because unlike most of the other commands with which we can use the pipe command to give them values, with the read command we cannot use the pipe. So for example, if I want to use the echo command and hello, and I want to pipe this into, for example, let's say the cat command, I can do like that. It's pretty straightforward. Problem is you cannot do that with the read command. So for example, let's say then I want to give the value of 10, and I want to pipe this into the read command. Read, let's say, into the variable w. But now if I try to access w, you will see that it is not set. So what we can do instead is to use the here string redirection. So for example, I can use read a, use the string redirection, where inside a I put something like green 45, and now you'll see that when I access a, I get what I want. And this is very useful not for just one variable, but most importantly when you use this for many variables like a, b, c, d, e, f, and I put inside green 45, 50, 60, 70, 80, 90, something like that. Now when I echo all these variables, I'll get all the values as we saw earlier. Now there is nothing new. It's just the process that we used of the here string redirection that was different. This is something really useful in general in bash scripting, and in particular this is something that we are going to use exactly in our script. Now in the script of this section we will use the grep command. And since I wanted to be sure that everyone knows how to use it, I added as a bonus here the full lesson on grep of my bash script crash course. So if you don't know about the grep command, you can learn about it here. Now if you want to search inside a file, the command that you need is grep, the grep command. Let's go inside new folder, And let's see what is inside btext. Now let's say that I want to look for a line where there is the word SO. So what I do, I simply type grep, and then I put what I am looking for. So for example, SO, and then the name of the file that I am searching, b.text. And it tells me, okay, I found something. And in fact, this is this one. Now, if you pay attention, you see that it didn't mention son. This is because grep is case sensitive. So if I were to do grep so, I would find that line instead, but not the first one. You see, it told me you can find son, but it didn't mention something. Very useful command. You should use grep usually always with this option. Very useful option is to make it non-sensitive. So you add the option in sensitive. I, and then we look for so inside btext, and you see that now it gives me both something and son, regardless to whether they are uppercase or lowercase. Of course, you can look for just S, and if you pay attention, you will see that it gives me all this line. And you have to remember that it's not just giving me the word starting with S, but the line that contained S. For example, here it's at the end, here it's at the beginning, here is in the middle. There is an S here, okay? So grep work in this way. Another useful way to use the command grep is with the pipe. For example, if I list everything I have here, something useful might be to look for something that has the letter T in it. So for example, I could go ls and then pipe into grep looking for T's, for example, and you see it gives me all these files. Very useful option for grep is -v, which gives you everything except what you put in the command grep. So if I do ls and I pipe it into grep -v t, you will find everything except these files that have T in them. And in fact, you see that it gives me everything else. So that's all for grep, and see you in the next lesson. So in this lesson we talk about internal field separator, and the question that brings us to the point is the following. Why is that, for example, when we do a read and we go like A, B, C, and D, and we hit enter and we write 10 space 20 space 30 space 40, we get 4 different variables. So if I go like echo $B, I get 20, and A I get 10, etc. But if I instead do 10 semicolon 20 semicolon 30 semicolon 40, what happened is that if I go inside the variable A, I get the whole thing. So everything was given in input to the variable A. And this is because the internal field separator, the separator that is considered as valid, is the space, okay? It's not the semicolon. And this is actually stored inside an environment variable, and you can access it by doing echo $ in EFS, standing for internal field separator. And of course you don't get anything because you're just seeing the space, so it's a bit tricky, but it's there. So the nice thing is that we can change this internal field separator. So let me open a script here and let me show you this. Let's create a variable x and let's store inside this variable the value AA, BB, CC, and DD. And if we do a for loop inside this, so for I inside x do, and let's echo I, done. Now if we run this script, I will loop through all this element of the string AA, BB, CC, and DD. Let's do that. Run my script, and as you can see we get all this element here, And this is because all these elements were considered as different, as separated by the internal field separator, that is the space. Okay, what if I instead write this, underscore this, underscore this, and underscore that? As you might expect, the result of this for will be just one loop, this one. So save this and run this. As you can see, we got an error. We got two elements because I forgot the space here, but this proves exactly the point. The only separator considered is the space. So if I delete this here and I save it and I run this again, you can see that there is just one item. Now the question is, as you remember from the previous lesson, many files contains information separated not by a space but by something else, like a column, a comma, an underscore, whatever it is. How can we make use of this? Well, the nice thing is that we can change the internal field separator. So we can go EFS equals something else. So in this case, for example, if I want to consider a separator as an underscore, I will just put the underscore. Now, before to move on with this, a good practice is always to revert at the end the normal value of the EFS. We don't want to risk our script to change an environment variable. It's hard. I mean, it's not as easy as that. Usually it will revert back to that, but we never want to mess around with environment variables. So what we do is we set an old EFS as the normal EFS so that the normal value is stored into this old EFS. Then we change it, and at the end of our script we revert the value of EFS to the old EFS so that everything goes back to normal. Let's just echo this out to be sure. Let's echo the value of EFS here. Let's write value of EFS here and value of EFS here so it is more readable. And let's proceed this loop with some asterisks just to make it more readable as well. So if I now run this, as you can see now, the value of EFS now is the underscore, and the loop goes through every one of this element A, B, B, C, C, and D, D. If you want to read some values like in a variable A, B, C, and D, you can now do that with a file like this. Hi underscore there how are. Now we will have 1, 2, 3, 4, 1, 2, 3, 4. Let's add another variable f here. Now in this case, the read command will think that the only variable that it has is this one because there's no space here. And remember, now the internal field separator is again the space. So there will be just one variable here. But if I move this line after this here the value of the EFS is still the underscore. Now this will be interpreted as a separator. Let's save it and run it to show you that. My script. And as you can see now we have that A is high, B is there, C is how, as we wanted here. Now we have all the pieces that we need to face our script. So we will see all the things that we learned again in this section put into practice in a simple but real world example. And again, at this point, if you follow up to this point and you practice this script should be quite easy to implement. So without further ado, let's go. In this lesson, I'm going to show you the script that we want to create. With this script, we want to be able to read complex files because many login files of Linux system are not files whose information are simply separated by spaces. For example, if we go into this file here and we open it with the last command, what we get is, it's a pretty important file actually. It is required during login and it contains a list of the system's accounts, and it gives for each account some useful information like the user ID here, the password, which is not shown here, it is shown in another file, the group ID, the home directory, the full name of the file, and so on. And as you can see, all this information, they're not separated simply by a space, but they're separated by a column. So if we want to use this information, we have to be able to parse this string to take information out of this string, considering each element separated from another, not by a space, but by a column. And in different cases, you can have different separator. Okay, what we want to be able to do with our script is to, let's say that I know and I'm interested in some user, for example, this user here, hid. Let's say that I want to know right away all the important information about this user without having to open this file, find out where this user is, and read every different information. Okay, so we will create a script like this that I called etc_read, just to remember that we want to read the etc file. We hit enter and it just ask us what is the user that we want to have information about. So we just type hid in this case. And what we get is the clear sequence of information about this user. The user, the path, the UID, the GID, the full name, the directory, and the shell. Of course, if we run this command on a user that is not present here, like whatever I write here, we will get something like this is not present in the etc password. So in order to do that, we will have to learn about how to use the redirection in the read command, and also about how to use the internal field separator of the terminal, which by default is the space. We will have to be able to change that in what we want and see what happens. And after we learn this, we will be able to actually create our script. So let's start right away. So in this lesson, finally, we create the script that take information from our etc passwd file, this one here. And I remind you that this script take an input, the name of a user, and give back all the information about this user. So on every line we have the username, then we have the password, then we have the user ID, then the group ID, then the full name, then we have the home directory of this user, and then we have the shell of this user. So given a name like Apple Pay here, for example, we run etc, we give the name Apple Pay, and we get all the information that we want. So how do we do that? Well, first of all, if you want to get information about a user, like for example the user Apple Pay here, we do that with the grep command. So we just use the grep command and we look for the string Apple Pay within this folder etc passwd. And as you can see, we get our line. Once we have this line, we have to take every information about this line, and every information about this line is divided by a column. So let's open a new file. Let's create a variable file with the name of our directory here. Let's start by considering a fixed username for now. Again, with the example of Apple Pay, then we will make this interactive. And now we want to save this line inside a variable so that we can then analyze it. Let's call this variable info. So to get this line, we just have to run this grep command here. And in particular, we have to use the command substitution to run this command grep. So we run grep onto this username variable, looking inside our directory here that we put inside the name file. To see that everything is working fine, let's echo out info and see what we get. So we save, let me close, let's run the etc program. And as you can see, we get our line. Now what we want to do is to put all this information divided by a column inside a different variable. So here we can use the read command and create a variable for every and each one of this element, starting from user, and then the password, and then the user ID, and then the group ID, and then the full name, let's call it full, then a home directory, let's call it home, and then the shell, let's call it simply shell. And we can use the here string command. So we redirect inside read, and in particular inside this variable, we redirect this string that was put inside info. So this string here, we just write info here. Let's now check it echoing out all of this variable. So user is and shell is shell. Now if we do like this, of course, as we explained in the previous lesson, this is not going to work, because as we said, all the information about the ATC, this ATC string, are divided by the column. What we can do is to set the internal field separator as, in this case, a column. And again, if we want to do this nicely, we first save inside the variable old IFS the value of the actual IFS, so that in the end we revert back the exact value of the IFS. So now if we save, let's revert this back. If we run this again, as you can see, we get all our information in the right way. And for example, the full name is Apple Pay account with a space inside, and this is taken into account by our program, giving us the right answer here. So the first thing to generalize this program is to make it interactive. So let's read from input the value of the username, and we save it under exactly username. So now we can get rid of this. Let's try this. Name of the username, let's try with MySQL, and we get this line here and all the information regarding this line. Of course, if we try with something that does not exist, we don't get anything. So we have to take care of that, and so just add an if condition. And we can use a condition like, if this string is not empty, then do all of this. Instead, else, if the string is empty, it means it didn't find it, so we can write user not found. So the way to check if a string is not empty is to use the option -n here, and then the name of the string, which is $info. Else echo user not found. Name, let's try whatever name like this, and we get user not found. Let's write back, for example, Apple Pay, and we get our information. So the nice thing is about this program is that you can tweak it as much as you want. You can change anything. You can make the program more interactive, so letting the user choose the file that he wants to search. For example, here we're fixing this file, but you can choose and change the file. And maybe, depending on what file you're searching, the field separator can change. Maybe in another file, the field separator is a semicolon or an underscore or whatever. And then, according to what separator there is, you can use this program with a different separator to do the same thing and take the information that you want. At this point, it just depends on what are your needs, but you learn really all the bricks to let you play with it and create whatever you want. So I wanted to show you that the scripts are exactly the same in any operating system that is Linux based. So for example, here I am in another system, in a particular on Ubuntu Linux, and I copied my program to this system too, and I saved it here, as you can see, ATC. Now I make it executable in the usual way. It's here, etc. So let's see, for example, in this system, what is inside etc passwd. As you can see, we have So we have all this line with the user, the password, the path, the full name, etc. And so let's say that we are interested in this user here, Pulse. So we just have to run our script, etc. And then we enter the name Pulse. And as you can see, everything works as usual, as it should. And we get the name of the user, the pass, the UID, the group ID, and the full name, and so on and so forth. In this lesson, I'm going to show you the script that we will be developing in this section, and the script is related to the path. We saw that the path environment variable is a variable like this that contains a list of all the directories that the system check in order to be able to execute a particular program, and it does that so that, for example, when we type ls is found inside one of those directories, and so it can be executed like that. The first problem is that this is pretty confusing. It's not, you have to really make an effort to see where a directory ends and where a directory starts. So the first thing and most simple thing that our program path will do, if you type it without any option and without any argument, we hit enter, the first thing that it does, it simply gives us a very clear and clean list of the directories that the path contains. The second thing that path does is with the option -c. So we will add the option -c as in command, and what it does, it tells us if the command that we will write here is present inside the path. So for example, let's say that I want to know if the ls command is present inside the path, and we know it is. We just run this in this way and we get an output. For example, I use this ugly way of presenting that, but you can choose whatever way you want to tell that this ls command is present, and it also tells me where it is present. So for example, if I use it for the grep command instead, I get that it is present and it is here. Now you might notice that up to this point this program do something similar to the which program. The which program, which is built in the terminal, built in the Unix system. For example, I want to know where ls command is present. I go which ls and I get, well, ls is present here. Or if I want to know where grep is present, I get, well, grep is present here. And it's in the same way that our command do. But our script will do something more. Two things actually. The first thing is that, let's say that I want to know where the command clear is present. So I go which clear and I get this. And this is almost correct in the sense that yes, clear is contained here, but the point is that clear, the command clear, is contained also in another directory. And so what our program do, path -c clear, it will show us where all the places in the path where the clear command is contained. So I hit enter, and as you can see, I can check that the clear command is contained here, opt local bean, but also here user bean. And you can really check that this is the case, because if I now run the command clear from this path, I hit enter, you see that it's actually running. But let's do that again. If I now run the command clear from this second path, that which was not showing, let me show you again. Clear just showing the first one, not the second one, not this one. If I now run clear from this, again, it is actually the command clear. So this is the second thing that our path program will do. And the third thing that our path program will do is with the second option, the option -d. So the thing that we want to know is if a particular folder is present in path. Now in this case, when you have a path like this, it can be not very difficult because it's not very long. But if you have a very, very long list inside the path, to know whether a folder is present or not, it can be very difficult. So the third thing that the path do is with the option -d. If I want to know if the user bin folder is found inside our list of directories inside path, I use the command in this way. And so for example, this is found. But if I go, for example, I don't know, I look for another folder, like for example desktop, it's not found, of course. And if I go user MacBook sum script instead, I get that it is found. And you can write this like this or without the final slash, it will work the same. And also you can use the shortcut to get, for example, to the home folder, which is the tilde. So this represents the home folder, and this is gonna work anyway, as you can see. So in the next lesson, we're gonna learn all the basics that will put us in a position to be able to create this exact script. So in this lesson, we will build our path script. So let's create an executable file called path, and let's open it, and here it is. So the first thing that we want to do is the simplest thing. So remember, try to start always with the simplest thing and add complexity as you go. So the first thing that we want to know is just to find a way to write this complicated path in a simple way, one line after the other. So what we want to do is just to get every and each one of these directories, and we already saw how to do that. So we just want to run a for loop, but before doing that, we want to change the internal field separator. So we will go like this. We set an old internal field separator as the actual EFS, and then we change the EFS to a column. And after that, we can run our for. So for I in path do, and we just want to echo out our value I. Done. Let's save it and let's try this. Let's run path. And as you can see, we get this path written in a very nice way. Let's call this variable loop in a way that it makes more sense. Let's call it dir. It doesn't change anything as long as we use the same name, but it's nice to help this. And at the end of this, of course, we want to revert the EFS to its previous value. We don't want to change anything. At this point, we can start working to the other feature of this command, maybe the most interesting one, which is to check if a command is present or not inside path. So we will do that using the option -c. So we will use that only if the option -c is used. And so we will check the first parameter that we give to our script, $1, is the string -c or not. And if it is -c, it means that we want to check if a command is present inside our path. And so we will save our command that we will give as an argument, my com. We will save it inside $2. At this point, we will run a loop that will loop within all the directories to check if this command is present in at least one of these directories. So let's run our loop for dir in path do what. Now that we are inside, let me show you this here. We're running a loop that goes through each one of these folders. And what we want to do is to see if this command is present in one of those directories. So if this file here, directory/command exists, and we know that we can use the option to tell if this command exists. So in this case, we write something like this, command present in path, and we also write where it is. So we echo out this exact path. So we close the if. Let's indent this properly. And after you check this, the for loop will go into the next directory and we'll check the same thing. So at this point, we close the for loop. And then we close this condition here. Close the if. And here in this if condition, I just forgot the then. So this is the proper syntax, if then and if then. Let's check if everything is working. So if I run path like this, I get the simple list of path. And if I run path with the option -c, and I write, for example, ls command, I get that this command is present in path. And now you see what we have to fix, which is I get this, but I also get all the list of directory inside path. I do not want that in the case that I'm using the option -c. So what we do here is we add an if condition here so that we run this only in case that nothing was added in path. So we add if $1 is the empty string column, then so in this case we will enter this only if the first argument is empty. So let's run this again. If I don't write anything, I get this. That's okay. If I run -c and I check for the else command, I get this, but I don't get inside this other loop, this other if condition here. We can check something nice with that the which command doesn't show us that, for example, is the clear command present in both of these instances, or also the my Python program is present in 2 different folder in path. Whereas if I were to use which Python, it would just give me the first one here. Let's put a comment here, clean list of, and so the last thing now that we want to do is to tell if a directory, not a command, if a directory is present or not in the list of path. So the first thing that we want to do is to tell that we will go inside this case if the first option is the -d option. So we will use exactly the same syntax here, but in the case of a -d. So if we have a -d, then the input as the second argument in this case will be a directory. So we can call it my_dir. Okay, so this is gonna be the second parameter, and we save it in my_dir, and then we run the usual loop within path. Now what we want to do is to check if my directory, now here it's slightly different from here. We don't want to know if this file exists. We want to know if this directory is one of these directories. So in that case, it means that this directory is present in path. That's one way to do that. There are many ways, of course. So what we can do is just use an if condition where we check if my_dir is the same of one of these directories here. And then in this case, we can write echo found. Now we close it. So let's try this. Let's use path with the -d option. Let's check, for example, if the user bean is inside the path. Yes, it is. In fact, you can see that it is here. Let's try something that we know it is not inside path. For example, user MacBook desktop. Okay, as you can see, we don't get anything. At this point, we can get rid of this first echo, just annoying. Let's try another one. It is always a good practice to try your script in slightly different scenarios so that you really get an idea of how it is working. So let's try this with this other folder, opt local spin, -d, opt local spin. And as you can see now, we see something that we don't like, which is not finding this one. And why is that? If you look carefully, what we typed here is almost the same as this one, but at the end we have this backslash. And why do we have that? Why did I put that? I didn't put that there. This is because when I use the autocompletion and I hit the tab to autocomplete, you see that at the end the autocompletion puts the backslash. Okay, so I didn't actually put that. So we have to take that into account because this folder actually belongs to the path. It's just that it has a backslash here. So we can do two things. We can add a comment on our script telling the user to be extra careful not adding a backslash here. But I prefer the second way, which is to change our script so that even in this case this is accepted. Okay, so we don't have to pay extra careful attention to what we're doing or what a user is doing here. And what we can do in this case is to tell our system in this if condition that the condition is met, not only in this case, but also if my directory that can contain this slash here is equal not to dir but to dir with an added slash. So here this is going to be okay in this case, or so we add the -o option as an or. My dir, so for example this is dir with an added slash. So for example in this case what I type here is exactly this one with an added slash at the end. So let's save it and let's try this again. Path -d local spin, and as you can see now it is found, and it is found even if I were to type it like that. So we ended the script, and now you really have a script that not only is very good for you to learn, but it's sure to be really useful. For example, I personally bring this script with me every time that I am on another system, on another computer, because it's very fast for me to have an idea of the path, or to have an idea whether some command is present or not in the script, and also to know how many times and in how many places a command might be present inside the path. And also when I am in some kind of folder and I want to know which folder are in the path and which are not, convenient way to check those folders in this way, like this is not present. Let me show you, for example, real quick the usage of this script inside an Ubuntu Linux system. So I'm here with our path script. So if we run this, we can check our path environment, and the first thing that you might notice is something that you want to avoid. For example, this directory here is present twice inside our path, and this is not bad, but you usually want to keep things clean. So it would be a nice thing for me now in this system to clear this directory. The second thing that I want to show you is, you remember that when we checked for the clear command in the Mac, we find two places where it was contained. If we do the same here and we check for the clear command using our script with the option -c, you see that we have that only in one place, in a user bin, and not in another directory also. So you might see this this difference in your system. And just to show you that everything works the same, again, for example, check if this folder here is present. And it is twice, as you can see, and it works even if we don't use the backslash here. But if we use something else like desktop or something else, we don't get anything. Okay, very good. So very, very good. I'm really happy that we arrived to this point, and let's move on learning the bash through real world examples in the next sections. So in this lesson, I'm going to show you the script that we will create in this section. And this script, which I called max_str as in string, is a script that read a file in input and find the longest string that this file contains. So for example, in this case, I have this file text.txt with all these words, and this can be as long as you want. And if I want to know the longest of this string here, I just run max string, and then I add the name of the file, which is text.txt. And I get that the longest string has length 11, and this string is the string grandmother here. Okay, so that's what we will do in the next lessons. In the script of this section, we are going to use the pipe command. And even though we're going to use that in a pretty simple way on its own, I wanted to give you a complete view on the pipe command. And it is why I took the whole lesson of the pipe command in my bash scripting crash course. And I put that here for your use. So if you want to know about the pipe command from scratch and know that a little bit more in detail, you can see that in the following lesson about pipe. In this lesson, we're gonna see this command here, the pipe command, and it lets you do the following.
lets you use the output of one command, let's say for example command 1, as the input of another command, let's say for example command 2. So if I want to list the content of a folder, I have this output here. What if I want to use the output of this command here as the input of the last command? So I want to look at this output, reading it with the last command. What I could do is I could do list a folder, and I would pipe in, that is the term you use, pipe in the output of ls a folder into the last command. If I do this, you can see that the output of list a folder was given as an input of less, so it's the same as less this input. Just to let you understand what it does actually, the pipe command is the same as doing the following. I could redirect the output of a folder inside a temporary file, temporary output file. So you can see, for example, if I read temporary output, there is this, and then I give the temporary output as the input of the command less, and I have the same result. So if you want to remember and understand how the pipe command works, you can remember this. The pipe command do the following: it takes the output of a command, it puts it inside a temporary file somewhere, and then it gives this to the last command. It uses this as an input of the last command or the second command, whatever command you might choose to use. Let's see some useful command that you can use with pipe. Let's read this file here. A useful command is the tail command, which let me see just the last, let's say the last 4 lines of a file, like btext. You can see I can read just the last 4 lines. So for example, I could use this command for, again, for some command like as a folder, and I can pipe this command into the tail, for example tail -3 command. So I will see just the last 3 lines of this output, and here they are. And one last thing is that you can pipe as many commands as you want. So for example, we can do this, we can pipe this into tail, the last 3 lines, and then I want to use this in turn as the input of the last command. The last command, and you see I obtained what I wanted. And really there's no end to these. I can also, for example, before that I can sort alphabetically the file. And as last thing, you can also pipe ls folder inside tail, the last 3 lines, and then pipe it inside sort, and then redirect this to some file, for example my new file.txt. Now if I watch my new file, you can see that I have the output of ls folder, of which I took only the last 3 lines, and then I sorted them in this file, my new file.txt. So we will see the pipe command in action in our script. Very good, and see you in the next lesson. In this lesson we will learn about the wc command, also known as the word count command. This is a command that takes as an input a file and counts the number of lines, of words, and of character of this file. For example, if we consider this file here, bob.txt, it has this 4 lines and a certain number of words and a certain number of characters. And if I want to know those numbers, I can go wc and then bob.txt. What I get here is the number of lines, and then the number of words, and then the number of characters
of this file. Now the first thing that you have to pay attention to is the number of lines, because when you see this file, we have that in the last line I have a new line. If I take this out, I erase this, and so now now when I'm in the fourth line, I cannot go anywhere, and I save that. Now what happened is that VC is gonna give me 3 as number of line, even though I have clearly 4 line. And this is because what it does, it actually counts the number of new line that I have in the file. Here I have a new line, here I have a second new line, here I have a third new line, but here I don't have a fourth new line. Okay, so what it actually does is counting the number of new lines. Okay, so you have to take that into account in this case. And for example, if you have to use the number of line, you have to add 1 to the number that you get here. Now, oftentimes this is used with some sort of pipe. So I can go, for example, echo hello, and I can pipe that, and I can pipe that into word count. And of course I have 1 word, 1 line, and 6 characters. And here it is clear. The second thing that I had to mention to you, that many times what happens is that in the word count, you have 1 more character than what you actually have. So this is 1, 2, 3, 4, and 5, and it counts 6 since this is inside a string. And it can happen many times. Well, without going into details about that, what you have to do with your word count command is to check right away with a string like that what is the number that it's going to give you. And then if you have to use the number of characters, remember that and subtract 1 from this number. This is the easiest way to go because different system can do different things, so you really want to check that. The most useful way to go about VC is to get only the number of one particular thing that you're interested in. So for example, only the number of lines, or only the number of words, or only the number of characters. And you can do that using an option. For example, if you just want a number of lines, you can go -L. So if I go like this and I go bob.txt, I get 3. If I want only the number of words, I go -W. Also, I can get only the number of bytes with the -C option. And I can get the number of characters of my file with the -M option. And as you can see, they're actually, most instances, they're actually the same, the number of character or the number of bytes of my txt file. So of course you can do the same thing here with a pipe. So A, B, C, D, E, F, G, J, and I pipe that into WC, for example. Number of line is of course 1, the number of words is 3, and I get the number of characters 13. And even here you can use, of course, the redirection, the input redirection, for example, the here string. Let's do WC, and then we use the here string, either 1, 2, 3, and I get the lines, the words, and the characters. Or, of course, also the here document with the end. Let's use the end of file like so. So we can go hi, and then we go end of file. And we have 1, 2, 3, and 4 lines. And we have 6 words, 1, 2, 3, 4, 5, and 6, and 23 characters. Of course, it does what it has to do, that is ignoring the end of file. It's not counting this as a line or as a word, as it should, because we just need that to close the here document command. A very practical use of the WC command is to count number of items inside, for example, a folder. A simple application of that is to, for example, go about the listing with the -L option of your file, which we know does that. And we pipe that into the word count with the number of lines. What I do in this way is that I will have the number of files in this folder in particular. So as you can see, again, 19. Just again, pay attention to the fact that, for example, here we have this line, and this is not a file. So if you need to use this number inside the script, you would subtract this number by 1, for example. And you can make it as fancy as you want. It depends really on what you need to do. But for example, you could count only the number of txt files. I could go ls minus l and then star txt. And we know that this is just going to give us the txt file. And so if I pipe that into wc minus l, this is going to give me the number of files. And this, in this case, we don't have that line here. So this is actually, so 9 is actually the number of txt file that I have here inside here. Okay, so this command is pretty useful, and we're going to use that in our script. In this lesson, we're going to learn about the strings command. This command take as an input a file and return each string of printable character inside that file. And its main use usually is to extract the text part of a file, disregarding the non-text part, because there are some binary files that has some text part in them, but also some binary parts that is a non-text. And what strings does, takes everything that is printable. But usually it's very useful with simple text file too, just to gather all the string within this text. So for example, again, if we consider our file bob.txt and we use the strings command in it, what it does, it gives us all the strings that are inside. So what you can do with the strings command, for example, is to save the output of this inside a variable. And again, there might be different ways to do that, of course, but the strings command really ensures you to just get the strings part, the printable character parts, and nothing else. Now, the useful part of the strings command, it is also its delicate part, because what you have to know, what you have to keep in mind, and I'm going to show you that in detail, is that strings by default just take the strings that are at least 4 character long. So for example, let's say that here I add a string that is 3 characters, and here 2 characters, and here 1 character, and here nothing, and I save. Okay, now if I do strings bob, you'll see that all these lines are omitted totally. To change that, we can use the option -n. So if I go -n and I tell, hey, I want also to consider all the strings that are, for example, at least 3 characters long. So I will go -n3. Now what is going to happen here? We're going to get this, and we're going to get this line too, because it has 3 characters, but not this too. In fact, if I hit enter, you can see the ABC is here. And if I want also the strings that are at least 2 characters, I would go 2, and we have AB. And if I want also the character with 1, I go -n1, and I have this. And finally, if I want all of it, I would just go -0, because as you can see here, there is no this new line, because there is a null character, a 0 length character here if you want. So if I go -0, I'm gonna get that too. And this might be a shortcoming to you at first, but actually this is the strength of the strings command, because if you know that you're looking just for a particular length, this command, it has built in itself the capacity of overlooking everything else. So it is very, very fast in doing that. If you think about that, if you have a file with 1 million strings in it, and most of them are 2 characters, 3 characters, and you're looking for a longer string, the first thing you should do is to pass this file to strings with the option, for example, -4. Okay, and this is going to do that in no time. But if you had to do that with a for loop, that'd be much, much longer. Okay, and there is a shortcut of this kind of expression. What you can do is to omit the -n and just go -3, for example, or -2. It will do exactly the same thing. It will give me all the strings that are at least 2 characters, for example, or whatever number you want here. So very good. This is another command that we will use in our script. So see you in the next lesson. So in this lesson, we will create the max string script. Now what we want to do is to run through every one of these words and check what is the longest. So we can use the string command, use a strings command on our file. So we can put it inside a variable called s, and so we will use the command expansion. So that now inside s we have all of this. Let's check it echoing out s. If everything is working, we should get the content of the file, and we actually do. Let's run a for inside s. For I in s, do echo I. Let's get rid of this. And now we should have a list of all the strings inside this file. And as you can see, we do have all of those. Now we have to work with the length of these strings. So we want to have the length of all of the strings. So how do we do that? So we can echo the value of $i, which is in our case our word, and we can pipe this into the command word count with the option -c, which counts the number of the letters. And let's see if this works. And as you can see, we have dog with 4, cat with 4, and again we have the issue that the word count -c add 1 to the number of letters. So this should be 3 is 4, this should be 1, 2, 3, 4, 5 is 6, and so on. So what we do, we put this value inside a variable first of all. So we use the command expansion, and then we set the value of length as length -1. We can use our command calc to make this computation. So we want to calc the very simple computation of length -1. And of course, again, we do that as a command expansion. So let's now echo this out in a clearer way. We just echo out the word and then the number of its letters. So $len. Let's run this. And as you can see, this is working. This is working good. The dog is 3 letters, cat 3, angel 5, and so on and so forth. Now it comes to the actual part where we find out what is the longest of these words. So what we want to do is to go through each one of those and use an if condition to check if this word has a length that is bigger than the previous one. If this happens, this word will become our reference word. If not, nothing happened. And so now we have a reference word of 3. Now we move on this one. This is bigger, so this is going to be our reference word instead. We move on. 3 is not greater than 5, so nothing happened, again nothing happened because 5 is again not greater than 5, nothing happened. And here we have that this word is the length that is bigger to our reference word, which is this one. So if 8 is greater than 5, then this one becomes our reference word, and so on and so forth. So at the end, we will have the longest word. So how do we do that? Well, we first set our reference word as an empty string, and our max length as 0. Now what we do, we use an if condition. If the length of this word is greater than our max length, so the maximum length that we found so far in the loop, then it means that this word I has a length that is greater than the length of our reference word. And so it means that our reference word must be this new word here. And also now the maximal length that we have must be exactly this length here. So max length must be equal to this length here. If not, we will not go inside this loop and the reference word will stay the same. So let's check now our biggest word, like max length is max length and longest word is reference word. Let's save and let's check if it is run correctly. Let's add the clear output here. And as you can see, we have that the max length is 11 and the longest word is grandmother, which is this one as we expected. So this is working. The last thing that I want to add to make this a little bit more correct is to check if the file that we're giving in as an input of this script is actually a good file, so it exists and it is readable. And so we know that we can do that with an if like that. If this file name is exists and is readable, so the minus r option, then all of this happen. Let me indent this, and we close here the if condition, and we also add an else condition to tell the user that the file is not readable. Not readable. Because otherwise this can create messy things if you try to do that with the file that does not exist or it's not readable. And of course this has to be put inside the if condition, so we will put that here. Let's try this again. With our file everything goes well, and let's start getting rid of this echo command here. We don't need that anymore. So it's going to be like this, and if we do that with a file that does not exist, we get file not readable. And let's add /known existing. The last thing that I want to show you is the other way that we could have gone to get the length of this string. Because once we have this, the I variable that is looping through every one of our words, we can simply get this length using the operation on variables. So we simply can use length equal and then $, the variable I. We know that this command give us the length of I, and we can get rid of those instead. Let's see if everything goes smooth. Anyway, I save. And as you can see, we still have the good answer. And one thing you might have noticed is that in this way it seems faster. It actually is. Let's see how much time this script take to run. So we use the command time, and we use max string apply to text. And if we run this like a couple of times so that we get to an average value, we have that this is about 0.06 second. If we instead were to use this way of computing length, and we take this out, so now we are using this, and you look at the time to compute our script, we get something like 1.7 seconds or 1.6. It is much slower, and this is due to two things. First, we are using an outside function inside this, and we're using that many times as the loop has to go for. And the second one is that we're performing this more complex action of echoing this and piping this into the command word count with this option. So this is much longer than using the built-in way to compute the length of the string of this way. And when you get a little bit better with scripts and you run those on very, very heavy files, you should start tweaking your script also for the sake of the speed of your script. So this is very good, and keep that in mind. So if you follow up to this point, I am very happy about that, because you're learning how to put together a really functional and real-world script. So I'm very glad about that. So let's keep learning and let's move on to the next section. In this lesson, we will talk about arrays. An array is a variable that holds more than one value at a time. And in general programming languages, they're organized like tables. For example, a two-dimensional array, you can think of it as a spreadsheet with its row and columns, and you can also have 3 or 4-dimensional arrays. The point is that in Bash, an array is limited to just one dimension. Okay, so you can think of it as just a row of elements or a column of elements, in whatever way you want to imagine this list of elements. Every element of an array is accessed using an address, and this address is called an index. The last thing that I want to tell you is that arrays are somewhat recent in the Unix world, because for example, when the shell, the sh came out, they didn't support arrays. It was only with the bash, so the born again shell, that arrays started to be supported, but yet they're pretty useful. So let's see in practice how they work. Let's say that I want to create an array called A. So I have to give the value of its element. So its element 0 is going to be expressed like that: A square brackets and then the 0 in it. And 0 is the index of this first element. Let's say that this is a string like bowl, and then I assign the string 1 glass, for example, and then A2 is a number like 22, and then A3 is another string, let's say a pencil. Now we can access every single one of those in the usual way. So if I want to access A0, I will go $, and then square brackets, and then A0, and I get my value. The only thing that you have to remember is that in this case with arrays, the curly braces are necessary. You cannot go like that as in normal variables. Okay, that's what you get. And so in the same way I can access, for example, the element 3 of the array, which is a pencil, or the element 2, which is 22, and so on and so forth. A nice way to assign values to an array is the following. Let's say that I have the array days. I can assign values to it in this way with round brackets, and then I put whatever I want. For example, mon to wet thir fry. Okay, this is a faster way to assign variables, to assign this value. And of course, if I want to access, for example, the element 0 of the array days, I'll go like that, days 0, and I get Monday. And the same goes for example, days element 3. Now, of course, you can change at any time the values of any element of an array. Let's say that I want to change the value of element 3. I can go days 3, I don't know, 33. So now if I access day 0, there's no change. Day 1, day 2, there's no change. But now day 3 is the new value set, 33. Usually you access the value of these arrays in a for loop. So let's see that. Let me recreate the array days here. Let's access the elements of this array with a for loop. For I in 0 dot dot for do element I is days I. Let's save it, or let's run this. That is how you usually access the element in an array. But let me show you something different. So I set again days like this. If you want to have all the elements of an array, you can use this expression. As we saw with the parameter of a script, you can use the @ sign. As you can see, we get them all. Or this sign, the star sign. But you have to be careful with that, because let's say that here I put a string a pencil, and here I put a string some nice thing. Let's run that. If we run that, we have the precise accessing of every element. But now we know that we also have this way of accessing an array. And so that give us all this element. So what we could do is to run a for, but in this way we could directly access our element in this. That gives us the list, the whole list of elements that we have. And so we can write our item is element,
Let's write an echo minus E just to clear these two outputs, and let's write a new line too. So what happened now if I type array is this is working properly, giving me one element at a time, but this is giving me mon 2, it's okay. But then when I get this, I have here that this is split. A is considered as one item and pencil as another item. And I might not want that, because usually you want to access the element of the array, not the single pieces of a string inside that. Okay, so how do you do that? You do that by simply adding commas here. And this is very important. If we do that, if I now save and I run that again, now you see that it's giving me the right output. So a pencil here and a pencil here, considered as a whole element, as it should in most cases. What I want to tell you is that, again, this notation with at is preferable to the star notation, because if I use the star notation, even with the commas, and I run that, you see that it's considered as a whole thing. Okay? Is not running through the elements. And even if I take out the commas, just to give you a complete view of what's happening here, and I run that, what is happening here is that this is splitting again in a bad way. This is giving me a pencil as two separate items. So just to wrap it up, what you want to do usually to access the elements inside a for loop, you use this expression with the at, and then you put the commas outside. Let's save, let's check that it is working. Let's go now back to our A. If you want to have the number of elements inside an array, let's create, for example, array B equal 10, 20, 30, hello. If I want the number of elements, I use the hash symbol here, and then I put B, and I ask for all the elements, so I use the at. It gives me 4 because I have 1, 2, 3, and 4 elements inside. All right. Now, if you're understanding what's happening with arrays, you can get the point that I can set values of an array of whatever index I want. I don't have to fill every index. So for example, I can set the value of 0 as in 0, and then I can set the value of 3 as in hey, and then I can set the value of, let's say, 7 as in 70. And then I can move, for example, to C2 equal 20. So I can be all over the place with arrays. I can fill whatever index I want. So now, for example, I have this. In this way, you understand that it's not easy to know which index is filled of an array. So for example, here the index 0, 3, 7, and 2 are filled, but not 5, not 10, not 1. Okay, so there's a way to know what indexes are filled, and this is very useful to know in arrays. And to know that, you have to use this expression, $, and then you access all of the elements, so C at, but then you put an exclamation mark or a bang here. You hit enter, and you see now that it's telling me the indexes that are filled. So the index 0, the index 2, the index 3, and the index 7. Incidentally, this is telling us also another thing that is useful to know. That is the biggest index that is filled. Because let's say that I want to append a value to C, append an element to C. If I don't know what is the maximum index, I cannot do that right away. But once I do that, I know that the 7 is the last item. And so, for example, now I can go C8 equals 80. And now C is this. A faster way to append some elements on an array is the following. You can go C, then you
press plus equal, and then you write whatever you want to append. So now here I can append 90 and string end. So now the array C have all of the previous, so this one, but also what I appended, that is 90 and end. The last thing that I can tell you is that you won't set an array in the same way as you unset the variable using unset. So if I go and set C, there's no more C, as you can see here. And also a little thing to notice is that the name of the array is considered to be the first element, or the element of index 0. So for example, if I assign something like here, like 120 to days, what I get now is that the first element is changed to 120. So days is the same as days 0. So in this lesson you saw a very powerful structure of bash scripting, which is arrays. You saw how to set those, how to access them, how to change their element through the indexes or with a for loop, how to count the numbers of them, how to append elements to them, and how to set or unset their values. This is something that we're going to use quite a bit in the script of our section. So very good, and see you in the next lesson. In this lesson we're going to learn about the cut command. You see, many times when you have the output of a file, for example, even the ls-l command, let's run that, and let's run that to, say, a particular file. What you get is a lot of information, and usually you don't want a whole information. Usually you just need a piece of this information, and maybe you need to store that. If you're running a script, you need to store that information somewhere and to change the behavior of your script accordingly to this piece of information. But you cannot do that with the whole thing. So cut lets you deal with that. Cut actually cuts a part of this output of a string of whatever, so that you can use that as in whatever way you want to. So let's see that in action. Let me start showing you this file here, bob.txt. The way cut works is, let's say that I want just the first character. So what I do is I go cut -c and then 1 and then the name of the file. So in this case, bob.txt. And as you can see, you get this, the first one. If you want just the third character, you can easily imagine that you put the number 3 here. So now I'm gonna get this third character. So LC, nothing, 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 and then L. Okay. There is a way to use cat not considering characters but considering bytes, and you would do that with the -b option, but I would not encourage you to do that, because to cut by bytes it's not very clear what you're doing. So you really have to know what you're doing there. Okay, I'm just telling you so that you know that this can happen, and in many cases this is gonna yield the same result as in cutting by characters, but again I would not recommend you that. So sticking with our cutting by character, let me put this file here so you remember what it looks like. You can also cut in ranges. So let's say I want to cut from the first up to the third character. I would do 1-3. As you can see, we get just the first, the second, and the third character. And another useful thing is that you can cut from a certain character up to the end. So for example, let's say that I want to cut from the third line up to the end. I would go 3-, as you can see, or from the fifth character, let's say, up to the end. And as you can see, it gives you everything from the fifth character up to the end. And this works also in the in the the opposite way. If you wanna get everything from the start up to, let's say, the fourth character, you would go -4, and this gives me the first 4 characters. You also have the option of getting single elements. Let's say that I want the first character, but I also want the third character. I would go 1, 3. And now I get the first and the third character, as you can see here. Of course, you can do that with as many characters as you want. So, for example, if I want the first, the third, and the fifth character, I would go 1, 3, 5. Of course, you can use the pipe command together with cut. So if you're piping something in, you pipe that into cut -c, I don't know, 2 up to 5. You see that you're gonna get this part. And everything that I showed you works in the same way, from the fourth character up to the end, and so on. And also you can redirect, so cut -c, third up to the end, for example, with a string redirection, string redirect, or using a here document. You got the point about this redirection. It was just a reminder for you. Now, the cut command with the -c option is extremely useful when you know exactly the character number that you want to cut. And this is good when you have an output that is always fixed in length. However, sometimes you have outputs that are not fixed in length, so you cannot know exactly which character number you will want to cut. In this case, you will need to know the field that you want to cut. For example, in this case, you have a first field separated by a second field and a third field, and then you have a first field here, and then again other fields, and they're separated by a space. Or if you want, between each field there is a delimiter that is a space in this case. How to deal with fields? We deal with fields using using a delimiter. Okay, so we have to tell the cut command what delimiter we're using. So let's see an example of this in action with a more rich file, and one that doesn't use a simple space as a delimiter, but for example uses a comma. Okay, so I have to use the cut command, and I have to tell it what kind of delimiter it has to use. So I go -d to tell it the delimiter, and then in commas I tell it what kind of delimiter I want. So in this case this is a comma. And then of course I have to specify to it which field do I want. Do I want the first field? Do I want the second field? Do I want the third field? In this case, let's say that I want the first field. So I go -f as in field, and then 1. And then let me put the name of the file. And as you can see, I'm getting the first field here. If I wanted the second field, of course, I would go, let's say the third field, I would go 3, and then the name of the file. And as you can see here, I'm getting third. Here I'm not getting anything because there's nothing. And then the third fields of this file, separated by this kind of delimiter. That would be totally a different thing if I were to use a space. As you can see, now I consider a space as a delimiter, so it's not understanding what's going on, and we get this output instead. So be specific with what delimiter you want. The nice thing is that we can use everything that we learn with the -c option also with the -d option, also in this delimiter case. So for example, let's say that I want the first, the second, and the third field. I would go cut -d delimiter, comma, and the field I would say 1-3, and then the name of the file, 2-bob.txt. And as you can see, we get only the first 3 fields. Or also, let's say that I want everything from the second field onward, I would go 2-, and as you can see, we get everything from the second field. Or everything up to the second field, that would be -2. Or if you want just particular fields. So for example, the first field and the fourth field, I will go 1, comma, fourth. As you can see now, we get the first and the fourth field. And again, even in this case, you can use the redirection and you can use pipe. So in this lesson, we'll learn about a command that allow us to cut specific parts of a file or of strings. And also, using the option of the delimiter, you can choose whatever field you want. So this is a pretty powerful command to use. And we're going to use that in our script. So stay tuned for the next topic. So very good, and see you in the next lesson. In this lesson, we're going to see the command stat. This command gives you detailed information about your files or folder in your system. And it is one of the rare and few exceptions where we have a command that behaves quite differently in a Linux Unix system like this one where we are now, or in a Mac Unix system. So in this lesson, I'm gonna show you the behavior of this useful command both in a Linux Unix system and in a Mac Unix system. We will start now on my Ubuntu Linux machine, and then we will switch to a Mac machine. So I'm here and I have those files inside my folder, and the basic use of stat is pretty simple. You go stat and then the file that you want to have information about, like for example, let's take this calc here. And as you can see, you get some information about it, like the file name, the size, the block, the inode numbers, the link that it has, and also the kind of access permission that it has, this in a human readable format or in an octal format here, and the user ID number and the user name, and the same for the group ID and the group name, and also the time that it was last accessed, the time that it was last modified, and the time that it was last changed. But the most useful way to go about this command is to get a specific information that you need about the file. And you can get the specific information with the option format. So you will go stat and then format. And then here you add the specification of the format, what exact piece of information you want. And you go something like the % and some letter that represent the specification that you want, and then of course the name of the file. So for example, let's start with something very simple so you get the idea. Let's say that I want the name of the file. I would go stat format and then %n as in name, and then the name of the file, of course, calc. And as you can see, I get my name. Now before I show you the other really useful and interesting information that you can get about this file, let me show you the short option way to do the same thing. Instead of format, you can go with the option -c. So this is exactly the same thing of this, except is less readable but faster. So we would use this, and as you can see, I get that. Now if you want to know about the permission of the file, you would go capital A, and in this way you get the permission in a human readable format with all the read and write and execute permission about every user. Now there are many options about this command, and you can check that in the manual page. As you can see here, there are many specifications that you can use, and that you can use when you are in the format option. And here they are. They're all this kind of specification that you can use, a lot of them. So you can really check those if you're interested in that, or in getting specific information about your file. It can go very advanced. What I want to tell you now is that when you have a certain specification, this can come in two ways, and you can access the two different ways of this specification, usually in a Linux Unix system, using the capital letter or the lowercase letter. So let me give you an example. We saw how stat -c and then %a on my file calc gave me the permission in a human readable format. If I want a permission in an octal format, or in an octal way, if you will, I would use the minus lowercase a. So this is telling me exactly the same information, but this is telling me that in an octal representation. We're not going to use that. Don't worry if you don't understand exactly what it is. Just remember that this is an octal decimal way of telling the same thing as this one. I just want you to understand now the difference, the two ways that the same specification can be given. For example, if we want to know the username of the owner of this file, we would go %U, and you see that the user, in fact, it's me. It's Fra. If you want to know the user ID of the owner, not the username, you would go %, lowercase u, and this is in fact the user ID of Fra. By the way, let me also tell you that in the system, the user ID is saved in an environment variable, and which you can access like so every time. UID. Then you can have the file type with %f. This is a regular file. If you're working with a directory, it's going to tell you that this is a directory, for example. If you want the total size of your file, is going to be %s, which is 365 bytes. Now, something that is very useful is the time. The time, for example, that the file was last accessed. You go about that with the %x, lowercase x, and it's tell you exactly the time it was last accessed. Now, it's not something that you're probably going to use, but I want to show you nonetheless, is that if you want this time in epochs, you would go X. Now, for those of you who don't know what it is, this epoch time or Unix time, it's just a way of expressing time. It's pretty peculiar, and it is the number of seconds that have passed since exactly the midnight of the 1st January 1970. Okay, you can get this information with the command date and plus %s. You're gonna get the epoch time. Of course, if I do that again, this is gonna move, as you can see. Usually this is not useful in an absolute way, but it is useful if you have to compute interval of times. But I just want to give you this brief parenthesis on the epoch times so that you know what kind of number that is. So let's go back to our stat command. Again, with X is the epoch time it was last accessed. If we want the time that it was last modified, we would use the Y. And again, in epoch time, it will be Y. And finally, the time it was last changed, you can access it with the %Z, and in epoch time you would guess that %Z. Now let's switch and move to the stat command in a Mac Unix system. Let's see how it works. Okay, so here in a Mac Unix system, the stat command is pretty similar, but not totally. For example, if you just go about a file, let's say that we have a file here, rename.sh. If we just use the command as we did in a Linux system, so stat rename, we do get information about this, but it's less readable than in the Linux system. So the first thing that I want to tell you is that if you want to have the information about this file in a similar output of the output that you saw on Linux in a more readable way, you have to use the -x option. And as you can see now, we have a pretty similar and clear output. Okay, if you want to use this command often and you don't want to type stat -x all the time, of course you can create an alias stat equal stat -x. Okay, and you can put that inside your login script. So now when I do stat rename, for example, I'm gonna get that without having to put the -x option. Okay, But let's undo that for now. An alias. Now let's see how we get detailed information about a file. We can do that with the -f option and then percent and the letter for the specification, and then of course the file. So for example, if you go stat -f and we want, starting again simple, the name of the file, we'll go percent capital N in this case, not lowercase n, capital N, and then rename, for example. Now if we want, for example, if we want the permission on the file, we will go percent. And as you can see, it's given in a pretty non-readable format. And what you have to know as, I would say, the only big difference between this command stat here on a Unix Mac is that if you want to have a human readable way to get this specification, you don't change this letter from lowercase to uppercase. What you do instead is you prepend, you put before a capital S. And this, in this case, stands for give me the output in a string readable way. Okay, so if I now put the S here, it's gonna give me the output of %p in a string readable way. So if I hit enter, as you can see now, I have the more readable permissions output of this file. And this goes for everything. So now that you know that for this, you can use that whenever you want. So for example, if we want the user, we go percent lowercase u, and this is the user ID. But if you want the username, which if you will is just a more human readable way of telling the user ID, you would go string capital S and then u. And as you can see, we get the username. The same goes for the group. If I want a group ID, I just go percent lowercase g. But if I want the group name, I would go capital S and then G. Now, if you have a Mac Unix system, I discovered that there are very few information on books and on internet about the stat command. So what I really recommend you to do would be to go to the man page and check for yourself. Let's say, for example, that we want to know the size of a file using the stat command. So, and we don't know how to do that, and we don't find that on the internet. We will go man and then stat. And here, there is a lot of information. What I suggest you to do is to use the search option inside the man. And you do that by typing the / that is going to appear here, and then type whatever you want to search. For example, want to search for word size. So you go size and I hit enter. So we get this. If you want to go to the next occurrence of size in this manual, in the manual page, you just hit the N key. So I press N and I go down, and as you can see now we find what we want. This is the size of files in bytes. This is the option. This is a specification that we want. So we quit pressing Q and I get here back. And so if I want the size, I just go Z and I get the size in bytes. Regarding the last time of access, you go %A, and this is in epochs. So now, would you know how to get the time not in epochs but in a human readable way? I guess you by this time you know. You just have to add an S here, and here you have your time in a human readable format. If you want the time of last modification, you go %M, and again in a human readable format that would be S. And lastly, if you want the last time, the time of the last change, you would go %C. So finally, we covered this command that gives you a lot of information about any file that you have, and we saw the differences between the usage of this command in a Linux Unix system and in a Mac Unix system. We will use this information to build a script that will work both on a Linux Unix system and on a Mac Unix system. So you're gonna see the first instance of a script that is portable, so you can run that on different machines, and we will see how we will do that. So very good, and see you in the next lesson. The script is the script modif, and it let us know how many times files inside a particular folder were modified, and this for each hour. For example, let's take this folder here. We have all these files inside, and they were modified at different times. Now if we run modif inside this folder and we hit enter, what we get is that at hour 0 no file were modified, at hour 1 0 file were modified, and so on. And then at 10 in the morning 1 file were modified. At, for example, 17 in the afternoon no file were modified. At 18 2 file were modified. And you can do that in for any folder that you want. For example, if we go back to the home folder, for example, we can do that with this temporary file. So we go here and we go in temporary. And again, you have an idea of when these files were modified. So most of the files were modified from 12 to 14, for example. And at the end, we get the total number of files. Also, we want to be sure that we're doing that in a folder and not on files or something else. So if we write something that is nothing, we directly go out from the script and we get this not there message. Or if we try to do that on a file like prox.m, again we get not there. So let's open our script and let's start taking as an argument the directory. Let's call it dir. Now let's also immediately check that this is a directory, otherwise we want to stop the script. So now we are into business. So the first thing that we want to know is when the files were modified, and for that we can use the stat command. Now I'm going to show you this both on a Mac Linux and on a Ubuntu Linux system. So let's start in the Mac. Here the stat command, as we saw, works something like this. We go stat, and then if we want the time that the file was modified, we go -m, -f, and then %S M, and then the name of the file. For example, let's do that on the calc, and we get this. At this point we're just interested in this number, and this number is 1 2 3 8 9 from the 8 and the 9 positions. So what we can do is that we can pipe this into the cat command -c, and we just take the 8 and the 9th letters. And as you can see, we get the right output. Of course, we can do that not only on calc, but on all of our program right here. So let me show you that. In this case, we have the time of modification of all the files inside some script. And again, we can pipe that into the cat command and just get the hours that are the thing that we're interested in. And so we have our nice list of times when our file were modified. And we can put the result in a variable called content or cont, let's say cont files. So we expand this command, and instead of doing that on all the files, we will do that in the file inside our directory. So we will go dir / all the files inside dir. Let's echo out this to check that everything is going smooth. Save. Let's run modif inside this directory. And as you can see, we get the hours that we saw earlier. So everything is working fine. Let's just check that if I type whatever, we get out, and yes, we do. So now what we want to do is to being able to count how many times a particular hour appeared here. So for example, 18 appeared twice, 20 appeared twice, 11 appeared just once, and so on. And we want to do that for every hour. Now there are a couple of or more ways to do that, but one clean way, and that allows you really to make your script more flexible, is to create an array that contains all the numbers of times that a particular hour appeared. So we want to create an array called hours, where, for example, let me give you an example. Hour 07, this guy here, must be the number of times that 07 appeared in this list. Okay, so in this case it's 0. And for example, hours in this case is 1 and 2. Okay, so the first thing that we want to do is we want to initialize this hours array, and we do that with a simple for. Of course, the hours are 24 from 0 to 24, so we go 4k in from 0 to 23, do hours k equals 0, done. Let's check that this is okay. Let's print all of them with this. Let's comment this, so we just have that here. And we have, this is initialized for 24. Now that we have that, we just have run a for inside count files. So inside, let me do that again, inside this list here, and count how many times every hour appeared. So we do that simply by run for inside count files. And what we do here, simply increasing the value of hours of the index I, because I is running on this. So if I get hour 18, it means that hour 18 must be increased from 0 to 1. Then I get to 18 again, and so hour 18 must be 1 plus 1, and so on. So we do that with this way, hours I equals hours I plus 1, and of course this is, we need another arithmetic expansion to do that, so we put double round brackets. Now let's print that to check that everything is fine. And as you can see, we get that hour 10 we get 1 instance, 11 and 12 1 instance, and then at hour number 20 we get 1, and at hour 18 we get 2, 19 1, 22, 21 1 instance, and 0 for the rest. Okay, so everything is working perfectly. Now we just want to output all of this in a nice way, so we're going to use the echo command with the -e option that will allow us to write with a tab, and then tab files, and let's write here something like this. Let's check this. Let's comment those also. And now we can print the values inside a for loop. For k in 0, 23, echo -e. We put the hours, that is just k, and then tab, and then the number of files is just hours, k. Done, save. Let's run this again. As you can see now, we get all the hours and the number of times that files were modified in this hour. So at hour 10 we get 1 modification, and for example at hour 18 files inside this folder were modified twice. At this point the basics of this program is finished, but what I want to tell you about arrays in general is that when you fill the index of an array, like in this case, you have to be careful that what you put inside is a clear integer. Okay, so for example in this case we're taking our I not from a list of numbers like so, like in this case, so we're 100% sure that everything is fine, but from this that is an expanded comment. Okay, so we have to be sure that the numbers are clear integers. And even more than that, and I want to show you what is the problem that can arise. Let me go to my home folder. Let us try this program on this library folder. And as you can see here, we get an error. The script modify in line 26, 08 value to grade, error token 08. So exactly in line 26, so here in our for loop, it says that we have a problem about the token 08. So probably we have something to deal with here. So when you have something like that, you want to be sure to see what's happening and where it is happening. So let's echo out every loop iteration here to see where exactly it happens. Let me clear the screen and do that again. And if you can see here, everything goes fine until we get to 08. when we get to 0.8, we get this error. Now you can understand what's happening. The array here doesn't want I to be taken from the 0.8. It wants a proper 8. The reason here is a little bit technical and has to do with the fact that the 0.8 will be interpreted here as an hexadecimal representation of a number. But even without knowing the details of that, it's pretty clear that 0.8 is not a good index for our array. So once we know that, we want to change every possible number that is 0.8, 0.7, 0 something into 8, 7, or a number without the 0 in front of it, because this comes from the hours, and the hours can be 0.8, but the index has to be 8. So that is what we want to do, and we do that using variables. We create another variable that is exactly I, except we strip off the 0 in front of it. So we want that a number like 0.08 becomes 8, and a number like 0.3 becomes 3. So we have this variable here 0.8, so we want to strip off the 0. So we saw that we can do that with the I, and then the hash, and then the character that we want to strip from the beginning. So hash 0. Save, let me comment this. And now hours will be filled not by I, but by j. So if I is a number like 13, j is not going to do anything because there is no 0 in 13, and j is going to be 13 as well. If I instead is a number like 0.8, j is going to be just 8. Let's see that this is what is happening, just to be sure. Let's echo out I and j. Let's run this again. And as you can see, everything is working fine. 15 is 15, 12 is 12. Then we have a 0, 0, which usually does not lead to a problem. That goes to 0. And we go, for example, 0.8 here is 8. And it doesn't stop here anymore. We don't get a problem anymore. So this is what we had to do. Let me take this out because everything is working fine now. Let me save and run this again like so, and we don't get any error, and we have that here, for example, at 8 we have 1 instance. So very well, we have our program, and the last thing that I wanna do is to show the result in a more clear way, because you see this is a very long list up to 23, and it would be nice to see the list split into the first 12 hours of the day and the second 12 hours of the day, as in the AM period and the PM period, if you will. And this technique that I'm gonna show you to do is a simple technique, but it's pretty useful in many cases. So let's do that. How do we do that? We do that in here. So we echo out this, but we want to print those up to 12 or 11. So we do like so. But of course, if we just do that, we're gonna just waste all the other element. We can add here another variable, let's call it m, that is exactly equal to k plus 12. And this is an arithmetic expression, so we use the proper assignment. Now we have that when k is 0, m is 12. When k is 1, m is 13, and so on. And so now what we can do is to print k and hours k, but also, let's put a tab here, m and hours with the index of m. So another tab, let's check it. So we do modify library. And as you can see, we have our hours file, and the hours goes up to 11. Then we have the file, and then we have the remaining hour. Let's finish this by making 2 tabs here. And hence 2 tabs here. Again, and now we have a pretty clean way of seeing that. It's very easy to read that. This is the morning hours and the number of times the files were modified at these hours, and we have the afternoon hours and the number of times that these were edited. It is no surprise, for example, that I see that I usually access and modify files in the PM hours and not in the AM hours. And it is also pretty clear that I don't usually wake up so early. If you can see, there's nothing going on before 10 in the morning. This is it can be pretty funny, but this is could be very useful information about the user activity. So now we saw this program for Linux in a Mac, and this is gonna work almost exactly the same of an Ubuntu system, except that this command is not going to work in an Ubuntu system. So what we're going to do now is to take this program and very fast see how we can change it. See first how we can change it for an Ubuntu system, but more interestingly, how to make this program portable, in the sense that we want a program that if we run this on a Mac Linux is going to work. If we run this on a Ubuntu Linux, it's going to work as well. So we'll do that in the next lesson. In this lesson, we're going to see how to make a script portable among different Unix distributions. And we will do that by learning something very simple yet very powerful about an environment, about a variable that let us know in what system we are. This variable is called OS type. Now, if you are on a Linux kind of system, this OS type will give an output to the string linux-gnu. Instead, if you're on a Mac operating system, this variable is gonna give you something like Darwin and something, usually a number after it. Let me show you that. Let's switch to a Mac operating system. So here we are on a Mac operating system, as you can see, and if I go OS type here, we get Darwin 17. The last thing that I want to tell you, just for sake of completeness, is that if you're, let's say that you're on a Windows system and you're running an emulator like Cygwin to emulate a Linux system, in that case, the OS type is gonna give you Cygwin. And in this case, it means you have an emulator of a Linux system, and so everything is exactly the same. So now that we know that, let's go back to our Linux system in Ubuntu and let's make our program portable. We will then check it both on Linux and on our Mac. So as you can see, we are here with our motif program, and if I try and run this here, I get an error about the stat, and we already know that because this is not the right syntax for stat inside a Linux system. Inside a Linux system, the right way to use stat in order to get the time of modification of a file is stat -c and then %_y and then the name of a file. Let's say, for example, calc. This is the right way to go. So we want to use this way of writing. So we want cont files to be this. And also we want to check about what kind of cut we want to add here. So for example, we can go, if you go cat -c and we go 07 to the end, we're gonna get this, and we want just this 16. So this is gonna be something like 12. Yes, 12, it's okay. We just want an hour, so we go 12, 13. Yes, this is what we want. So here we pipe it into cat -c 12, 13. If I comment this and now I use this, this is gonna work. Let me show you that. So I go motif dot and everything works fine. But now if I then use this program on a Mac, it's gonna get in turn a problem because you will not recognize this. So what we do is we use an if condition to check if we want to use this or that. And this if condition is to check that the OS type is that of a Mac or that of a Linux system. So for example, in a Linux system, it's gonna be something like Linux GNU. Let me use the double brackets. Then if this is a Linux system, we want to use this value. Let's also check for the first time that everything is okay. Writing we are in Linux. So I could use an else condition, but I'll just copy and paste this one. Let me be lazy for once. If instead this is something like Darwin, and now it can be Darwin some numbers. So after that, I'm gonna put this to indicate that it can be something else. So in this case, we want count file to be this. And in this case, we are in Mac. So let me save it and let's check this. And as you can see, it understands that we are in Linux and everything works fine. And also if we go, let's say, to our home directory and I run this, you can see that everything is working fine. So let me now copy this and use this on a Mac just to show you that this program is really portable. Okay, so it's gonna work as it is on a Mac too. So we are back now in our Mac system and we have our modif script here and it was working there, so we have to check if it is working here too. So let's run this. And as you can see, we are in Mac and everything is working perfectly. So we created a portable program in different system. Very good. Our script is ended here. If you followed until this point, congratulations, and let's move on.
Congratulations for making it so far, because in this course you were following not just pieces of theory, but you were really learning how to put those pieces together to solve a real problem, to create real world scripts. And that, I think, is the ultimate goal for a programmer or anyone that wants to learn a new skill. So I'm very glad about that. And remember that if you want to review some particular topic, every lesson in this course has a title with the main topic that is covered in that lesson. So for example, if you want to refresh your memory about wildcards, it's going to be very easy to do so. Or if you want to review variable manipulation, or if you want to review how subshells work, everything is very oriented on one topic, one lesson. So it's really like a small chapter of a book devoted to one topic alone. Now, if there is anything you want to ask me or any suggestion you want to give me, I will be very happy to read about that. I reply to every single one of your questions or comment, as you can directly check in the Q&A section. There's no question that is left unanswered. And if you like this course, I would really appreciate you to leave a review. Not only because of course it's good for me and it is good for the course, but I truly believe that this kind of learning, that this project base should be pushed. So I was very glad to have you as a student and talk to you soon in the course.